During the walk-around, you must check several items which are part of the fuel system. These items are not major components, but a check of their condition is very important.
Fuel can be measured manually by the magnetic fuel level indicators located under each wing and center tanks. The magnetic fuel level indicator should be flush with the aircraft surface. Each tank has water drain valves. You should check that there is no water leaking from the valve. If there is a leak, call the maintenance. A refuel panel is located on the fuselage, beneath the right-hand wing. A second and a third panel is installed near the refuel couplings.
Two refuel couplings are installed under the wings. These couplings allow refueling from both the right and left sides of the aircraft. Note, when both side couplings are used, refueling time is approximately 33 minutes for all tanks.
A surge tank is connected to the outer tank in each wing tip and on the right-hand side of the trim tank. These small tanks protect the system against overpressure and thermal expansion. The surge tank inlet should be clear of any blockage. The fuel ventilation overpressure disc should be intact. Note: the disc is intact when a white painted cross is in view. You should check that there is no fuel leaking from the shroud drain mast located on the belly fairing. The items related to the fuel system during the walk around are complete. We will now discuss items related to the fuel system that you will encounter during cockpit preparation. To better illustrate what occurs, we will select the ECAM fuel page for you. With the pumps in the off position, observe the symbology on the ECAM fuel page. The pumps are cross-line amber. During cockpit preparation, all white lights in the cockpit must be turned off. We will do it for you. As soon as one pump has been switched to on, the related indication becomes in line green on the ECAM fuel page, indicating that the pump is running. On the fuel panel, all fuel pumps have been set to on. But, as you can see on the fuel page, only the main pumps of the inner tanks and the center tank pumps are running. Green and line. Note, the standby pumps are not running. Green cross line. As these pumps will start if at least one of the related main pump fails or has been switched off. In this configuration, the Fuel Control and Monitoring System, FCMS, controls the fuel system automatically. Before you continue, you observe a message on the engine warning display. A green message, "Refuel in process," will be displayed on the engine warning display memo if the refuel control panel is not correctly set for flight. Note, after engine start, the message will change to "Refuel panel" in amber if refuel panel controls are not set for flight and the access door is not closed. A few minutes later, you observe that the refueling message on the engine warning display has disappeared, indicating that refuel controls are correctly set for flight, and the access door is closed. We have entered the zero fuel weight CG, the zero fuel weight, and the block fuel in the MCDU for you. You have to check that the estimated data, the trip fuel, the route reserve fuel, the alternate fuel, the final fuel, the extra fuel, the takeoff weight, and the landing weight correspond to the data on your computerized flight plan. Then, you have to check that the entered data correspond to the data from the load and trim sheet. For that, compare the zero fuel weight CG, zero fuel weight, with the previously entered data and adjust, if necessary. Also, check the load sheet CG against the ECAM CG.
Also verify the fuel distribution in the different tanks.
We have started the APU for you. The green triangle of the ECAM fuel page indicates that the APU low pressure valve is open and fuel is fed to the APU.
The items related to the fuel system during cockpit preparation are complete. We will now discuss items related to the fuel system that you will encounter during engine start. The indications and starting procedures are the same for both engines.
Normally, during engine start, the ECAM engine page will be automatically displayed. For training purposes only, to better illustrate what occurs in the fuel system, the ECAM fuel page will be presented. Before we start the engine, observe the following. The engine low pressure valves are cross line amber to indicate closure. The fuel used quantities remain from the previous flight, and engine identification numbers are amber. This is because the engines are not running. Engine 1 has been started. Observe. The engine low pressure valve is open. In line green, the fuel used indication automatically resets to 0 and begins to calculate the new engine fuel used. Engine identification number 1 changes to white, and the fuel flow starts to increase. Note: the fuel flow 1+2 indication is an option. The second engine has been started for you. The engines are fed by their engine feed pumps using fuel from the associated collector cells. The APU can now be stopped.
We will now discuss items related to the fuel system operation in flight.
The engines are always fed from their collector cell with fuel from the inner tanks by means of the running pump. Note: the indication of the trim tank isolation and inlet valves is shown closed as long as the landing gear or slats are extended. As there is fuel in the center tank is emptied first by transferring its fuel content to the inner tanks through the inner tank inlet valves. The inner tank inlet valves operate independently and cycle their respective inner tank content between underflow level and high level. Note: underflow level is at around 2000 kilo below high level.
When the center tank is empty, the pumps turn off automatically and both inner tank inlet valves close. The trim tank transfer system controls the center of gravity (CG) of the aircraft. When the aircraft is in cruise, The Fuel Control and Management Computer, FCMC, calculates the center of gravity and compares the result to a target value which depends on the aircraft's actual weight. From this calculation, the FCMC optimizes the center of gravity position by deciding the quantity of fuel to be transferred to the trim tank aft transfer or from the trim tank forward transfer. This optimization saves fuel by reducing the aircraft drag.
If the actual CG is forward of the target CG, and the aircraft is above flight level 255, an aft transfer occurs, as indicated by the green arrows on the ECAM fuel page. Fuel for the trim tank aft transfer can be provided also by the center tank unless it is empty. This transfer will automatically stop when the actual CG reaches the target CG minus 0.5%. Note, if during the transfer, the inner tanks are out of balance by more than 500 kilos, the transfer is automatically stopped on the lightest side until the fuel balance is recovered. When fuel is consumed, the actual CG increases. A forward transfer occurs automatically when the actual CG reaches the target CG. A forward transfer is normally directed to the inner tanks and may be directed to the center tank when it is not empty. On the memo display, trim tank transfer appears in green during the trim tank transfer. The forward transfer automatically stops when the actual CG is back to the target CG minus 0.5%, and so on, during the flight. As soon as one inner tank content reaches 4,000 kilos, a forward transfer occurs to cycle the fuel in the inner tanks between 4,000 kilos and 5,000 kilos until the trim tank is empty. Note, if during the transfer, the inner tanks are out of balance by more than 500 kilos, the transfer is automatically stopped on the heaviest side until the fuel balance is recovered. A continuous forward transfer also occurs when descending through flight level 245, or when time to destination, given by the FMGS, is less than 35 minutes. If the trim tank forward transfer pump has failed, The transfer occurs when time to destination is less than 75 minutes. Gravity transfer. The forward transfer will stop automatically when the landing gear or the slats are extended, whichever occurs first. Note: if an inner tank reaches the high level, the transfer stops to prevent a tank overflow, and restarts when the quantity reaches 2,000 kilos below the high level. The trim tank has been emptied, as shown by the indications on the ECAM fuel page. The message, "Trim tank transferred," is displayed in green on the ECAM memo. As soon as one inner tank quantity drops below 3,500 kilos, and the trim tank is empty, the outer tank transfer valves open to cycle the inner tank content between 3,500 kilos and 4,000 kilos. The outer to inner tanks transfer is done by gravity. The outer to inner tanks transfer is indicated on the ECAM fuel page by the appropriate symbol in either outer tank, and on the ECAM memo by the message "outer tank transfer," displayed in green. The outer tank transfer valves will close automatically when the outer tanks are empty for 5 minutes. The outer tanks are now empty, as shown by the indications on the ECAM fuel page. The message, "Outer tank transferred," is displayed on the ECAM memo. The items related to the fuel system in flight are complete. After landing, the first action is to start the APU, then you can stop the engines.